So I want to just recap from what happened Friday, where we did a little more on chapter 2.6, and then we started 2.7. So for 2.6, I talked about the limit for cosine does not exist, and then we talked about the inverse tangent function, and then I did some examples with inverse tangent, and we started 2.7. Yeah, and then we're going to do notes today. We review Wednesday, and the test will be up by midnight. And then the following Wednesday, the test will close. But if you do need more time, let me know. I can open it back up. We just want to try to stay on schedule. But I'm even behind schedule, so we'll make it work. 2.7 notes. So let's see. So probably a little bit we can put in from last time. We had a definition for the slope of the tangent line. M for slope. Sorry if I shake. Will be the limit as x goes to a of f of x minus f of a over x minus a. We did an example, and then we're going to do a new example. So for f of x equal to 1 over x at the point 1, 1. Part A, find the slope of the tangent line. Okay, oops, we need the limit as x goes to a. Let's just put in the formula of f of x minus f of a over x minus a. F of x is 1 over x, so 1 over x minus 1 over a over that denominator. I think I got a common denominator. Let's see. No. X goes to, I have a equal to 1. Okay. That was that point 1, 1. So limit as x goes to 1, let me see, of 1 over x minus 1 over 1. So okay. So we've got 1 over x minus 1 over x minus 1. And then I'd start to put in 1, and then I put that little note. We talked about it Friday, that if you have something that looks like this would be 1 minus 1, so 0 divided by, put this here, and you get 0. Try something that's like some kind of trick. Okay. What did I do? I multiplied everything by x. So you'd have x over x is 1 minus x over x squared minus x. Cool. All right, next. I factored an x out of the denominator. So these are almost like terms. So let's take a negative out of here. And put that negative sign. What did I do? I put, well, I guess we can still do this. I put parentheses around this and then make a negative of everything. Or I could have just taken a negative sign out of the numerator. This is fine. So that reduces, you've got a negative 1 over x. Then you can put, let's make sure. Yes, now we can put 1 in. There's no 0 in the denominator, no issues, and the limit is negative 1. Okay. Oh, and the next part is to find the equation of the tangent line. So that's the slope of the tangent line, and now we use an equation of a line to find this specific tangent line. So our slope is negative 1, and let's use the 0.11. Minus 1 equal to negative x plus 1. So negative x plus 2. And so last time we drew a picture, which I'm kind of thinking, should we draw it again? Yes. Let's draw the picture again of what we're doing. So we have some kind of function. So if you were at the Friday lecture, you've seen this before. So there's this point P, and then this is the line that's tangent to the curve at that point. And then we have the point Q over here. Here's X, and we called this, no, but this called this A, and this is X. We have X going to A to find the slope of the tangent line at that point P. Okay, so we have a new picture, which I'll put more detail into. Sort of similar. Okay, so starting fresh with a new idea is similar function. Yeah, so tangent line at a point P. Okay, the point. I do have it at X equals A, so this is the point A, F of A. And then what we do is we put some positive H, A plus H, over here. So that would be the point A plus H, F of A plus H. So your input is A plus H, and then put it through the function F, which is really hard to read. Okay, so F of A plus H, close those parentheses, and then parentheses around the whole thing. So it's the ordered pair A plus H, F of A plus H. Anywho, we have H go to 0, so H gets smaller and smaller and smaller. So at this point, called it Q, gets closer to P, and those secant lines approach the tangent line. So we'll do the limit as H goes to 0. Of F of A minus F of A plus H. So it's the difference between the Y values there. F of A plus H minus F of A. And then you do A plus H minus A. Okay, so you have an F of A plus H. Subtract F of A. You have a plus A plus H minus A, so just over H. So I guess I'm just noticing that at I want to remind you that m is the slope of the tangent line. So you can do it two ways, the way that we had in the last example or this way. We'll do an example and then I'll put the two options down afterwards. Okay. Okay, I feel like we can just jump into an example. Like pretty much this is all there is to the definition, and just a reminder, that's the slope of the tangent line. You can find it by taking the limit as h goes to 0, some positive number h of f of a plus h minus f of a over h. Try one. So it's f of x equals x squared minus 3x plus 5. And find the slope of the tangent line at the point 2, 3. This is going to be a lot of work. First, I think we're going to need to put the whiteboard sideways. Okay, we are going to put a plus h into the function, and then we're going to subtract putting in a. So I guess if you need a moment to write down the example, also before we get started, everybody say hi to Carlos. Taking a nap. Having a good day. Okay, we'll try the problem. All right, I've never done this before, but cool. Nope. The limit is h goes to 0. F of a plus h subtract f of a over h. Let's do f of a plus h. A plus h squared minus 3 times a plus h plus 5. So we just took care of that input. Subtract f of a, so we just put a into that function. A squared minus 3a plus 5. Okay, it's all over h. Let's do scratch work from here to here. Okay. A squared plus 2AH plus H squared. Minus 3A minus 3H plus 5. Minus A squared plus 3A. So the whole numerator is what we're taking care of. Minus 5. That's going to cancel. So will those 3A and a negative 3A? Oh, A squared and a negative A squared. So we've got 2AH. Or let's start with the H squared plus 2AH minus 3H. Okay. Factor out an H. H plus 2A minus 3. Over H. Then the H over H reduces to 1, and then we can take the limit after that. So space. Okay, so we're continuing on where the H's have reduced down, and we have the limit. H goes to 0 of H plus 2A. Make sure I have this correct. I feel like something may have gone wrong. Looking at my notes. I had more canceling happen. Let's try again, I guess. So it may, I think a mistake happened, so it may be okay, but I need to try everything over. No. Okay. Oh, I know what went wrong. We have a value for A. It's at the point 2, 3. So that's the problem. I was doing everything with just variables, which is okay. And I could have just put in that number for A, but let me show you how I worked out the problem. So kind of starting over. So I feel like the work we did was okay. It's just I want to be more specific. So we're doing the limit for the slope as the limit as H goes to 0 of f of number 2 plus H. Okay, and then f of 2 over H. Okay, so it's the same sort of idea. The limit as H goes to 0. And we have 2 plus H squared subtract 3 times 2 plus h and then add 5. That's this part. Then minus f of 2. 2 squared minus 3 times 2. And then everything was over h. Okay, so again, multiply to get 4 plus, let's see, 4h plus h squared. We'll do that on the side. All right. 4 plus 4h plus h squared. Minus 6 plus, minus 6 minus 3h. So cool. Add 5 and then minus. This would be 4 minus 6 plus 5. So we've got 3. 4 minus 6, negative 2. So it will be a minus 3. Just checking my sign. I think we're good to go. This one, and the limit as h goes to 0 of h squared plus h. Got 4 minus 6 plus 5. So then minus 3. Should add to 0. So 4, well here, negative 6 and positive 5, that's minus 1. 4 minus 1 is 3, and then positive 3 minus 3. Nothing left over. This looks better. Don't forget the denominator. Now we can factor out an h from the numerator. And then have the h's cancel or reduce. Take the limit as h goes to 0 of h plus 1. So h is going to 0 and the limit equals 1. Cool, that was much better. So we could have done the problem the previous way, it's just messy. So again, there are 2 ways to get the slope. You can either do it this way, where you have an h that goes to 0, and put in f of, let's write it down. Any questions though about the example?
No, seems pretty good.
All right, let's go back. Okay, so here we are. Just a reminder to find the slope of a tangent line. You can do the limit as h goes to 0. F of a plus h subtract f of a over h. Take the limit as x goes to a. F of x minus f of a over x minus a. Oh, cool. So another example. Find the slope of the tangent line to the following function. Let's see, copy. All right. Your function is the square root of 2x minus 3. Used the limit as h goes to 0. F of a plus h. Subtract. Let's put in, oh, we need a point. Let's see, at, oh, actually I didn't even use a point. I just put it in general. Oh, cool, at different points. Okay, so this is where I put the problem, or I did the problem like how I started the last one, where I don't have any point. I'm just gonna find the formula for the slope, and then I'll show you what you can have at different values of x. So we will put in a plus h. Take away f of a, everything over h. Okay, the root of 2 times a plus h minus 3. Oh, this is going to be messy. Minus root 2a minus 3. And everything is over h. Okay, we will need to multiply by conjugates with a conjugate, which will take up a lot of space. So we'll multiply the numerator and denominator by this root plus that root over itself. Back to sideways. We're gonna need a lot of space. Say 2 times a plus h minus 3. Okay, so I'm just going to copy down, but with a different sign in the middle, what this is. Again, Multiply here and take away the root. It's like foiling the numerators here. Positive one of these and a negative one of those, which is why we chose the conjugate, so that the middle is gone. Subtract. The root of 2a minus 3 times itself, so the 2a minus 3 is left. Okay, but we still have h times. I just wrote everything like as it is. Okay. Can we factor out an h, or what happens? I think it actually just, everything cancels out nicely. So let's just check out this numerator here. 2a 2a plus 2h minus 3 minus 2a. That was supposed to be plus 3. So it leaves 2h. And we can make okay, 2h over h times all this stuff. Oh man, we got this. Okay, h over h is 1. You know, people do this. 2 over that. Cool. Let's let h go to 0 now. So this is going to go to 0. And you'll have a root of 2a minus 3 plus another root of 2a minus 3. So there's 2 of those. 2 over 2. Let's write it down. 2 over 2 of these. And then we'll have a 1 over the root of 2a minus 3. Good. All right, so I just kind of worked with this a little bit more for the example. I put down that you can find the slope at different values of x. One of them I found was x equals 2. So the slope at x equals 2. is m for slope of 1 over the root of 2 minus 2, 2 times 2 minus 3. All right, a 1 over root 1 is going to be 1. I found the slope at x equals 6. The slope of the tangent line, to be more specific. Tangent line. X equal to 6 is. What did we get? 1 over 2 times 6. 1 over the root. And I think we're out of time. So we'll wrap it up in a sec. 1 over root 2 times 6 minus 3. 1 over root 2. And then I was going to find the equation of the tangent line, but I feel like that's something that we understand. So we've gotten to a place where I was going to talk about the definition of a derivative and then introduce velocity. Actually, we've talked about velocity and instantaneous velocity, but using this chapter's notes. So we'll get back to this on Friday. On Wednesday, we're going to review, which means work on practice problems. So that's the end for